Okay, you ready? You ready to do this?
Ready to do this?
Okay. So this is for...
This is for...
Can you read it?
Can I read it?
What does it say?
Process that shapes the earth.
Processes that shape the earth. Okay. So, and as mentioned before, we did look at this video before, and I was kind of brainstorming how to possibly go about it. I think I have a couple of videos that might be good. Hopefully the first one that I've got will kind of cover the same stuff. But so we're going to go through, watch this, and then we'll watch the one that I found on YouTube and see if we can get a little discussion about it, huh?
Oh.
Okay. Remember this? Ready? Okay.
Okay.
And
Ready? 1, 2, 3. 3. There we go. Perfect.
Good job. Okay. I'm going to turn it on, okay? I'm going to turn it up so we can hear, okay?
Look at the landscape around you. It's hard to believe that the land on which you stand today, where your home and school is built, where you hang out with your friends, may once have been covered in ocean water, or even ice and glaciers. This probably wasn't the case 10 years ago, or 100 years ago, or even 800 years ago. But it might have been the case tens of thousands to millions of years ago. Earth's landscape is constantly changing, though it often changes so slowly that humans don't notice it on an everyday basis. Scientists who study these landscapes and the clues that help us understand how they have changed over time are called geologists. Geologists examine a variety of clues to build an idea of what
Geologists.
Mm-hmm.
Geologists.
What's your phrase?
Geologists.
Geology rocks.
Geology rocks.
world looked like many years ago. They examine layers of rock and structures found in amazing places, such as the Grand Canyon in Arizona, or the Arbol de Piedra in Bolivia, or the Giant's Causeway in Northern Ireland. Geologists study what these rocks are made of and look for fossils of plants and animals found in these rocks. The incredible work that geologists have done has led us to understand that the rock walls that run hundreds of feet deep in the Grand Canyon were actually carved out over thousands of years by the slow but steady force of the Colorado River. Geologists' work has helped us to understand that some of the most beautiful beachside cliffs and arches were formed by the work of weathering and erosion caused by the persistent waves over time. This work even helps us understand how certain forces and processes that happen at a faster pace, such as natural disasters, have affected the landscape. Volcanoes, earthquakes, floods, and tsunamis alike transform the landscape of a region and affect the people and life that live in that region. Though they may be slow, the processes that change the earth are incredibly important. Next time you are outside, just try and imagine how the landscape around you may have looked different 10,000 years ago. What could have possibly caused strong, sturdy structures like mountains to change over time?
Okay. So how do we do this? Are we going to go to the video first? I kind of want to try something. I have an idea. We can almost simulate it. I should have thought of this before too, but let's see how this video does. What's this? What does it say?
Videos.
Booking a family vacation in a Virgo means leaving all the craziness behind. Well, maybe not all of it.
Commercials.
The surface of the Earth has so many different forms,
Look at that.
shapes, and colors.
Save
Okay.
some
It's not hard
colors.
to understand
Look
why
at the landscape around you.
Okay, wait. Pause on this one. Okay. So you remember we were talking about... Hey, wait. Let me show you. Okay. Remember how we were talking about this? We have the way the water moves and the way it takes away all of the little grains of sand. It moves everything, right? Like if we take a little container full of sand, I want to take a container full of sand and kind of pour some water onto it to kind of demonstrate the idea, especially if we can make like a little stream. But
This is 99.99 each.
what?
This is this one it says 99.99 each.
Look at this. See how these mountains are all up here?
Mountains are up here.
So all of this before, this was all full of water
Red
before.
and horizon.
This was like, see the little lake right here?
There's a lake right here.
See? There's a lake.
There's a lake.
Are you looking? Look.
Are you looking? Look.
So there's a little lake right there. See the guy next to the lake?
So the leg.
If that lake,
The egg.
if that lake dries up,
The lake dries up.
it's going to look more like this.
It's more like this.
You can kind of see where the water was,
That's where the water was.
right?
Right.
So as
As
the water
the
moves,
water moves,
it takes all of the
it
dirt
just over the dirt.
and it's going to take it away. And it
Just
makes a
take
big
it away.
hole.
A big hole.
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 A big hole.
A big hole.
Let's watch. Okay.
Let's watch.
Early
Okay.
scientists had a hard time determining what
Wait,
was
no,
responsible
no, don't start that one. That one's a different one.
for our natural world.
This work even helps us.
Watch this.
No.
Look at that.
In the early 19th
That is
century,
cool.
Most European scientists believed that volcanoes
Let's make
and
it big.
earthquakes were the primary forces that created the landscape around us.
Look at that.
No.
From the highest mountains
No, no.
deepest
Helps us
valleys
understand how.
Hey.
and the vast open spaces
Watch.
that lie in between.
Whoa.
But in 1858, an American geologist named John Newberry changed that thinking after he arrived in the Grand Canyon.
Okay. Whoa, look at that. Okay. You see this? You see all these little lines?
These little lines?
All those lines are where the water was. The water was totally
It's
full.
Totally full.
And the water, the water is pulling everything with it. And it made it into this shape. So all this was full of water at one point. And you can see the river now. You see the river down here?
Now. There's a river down here.
It's kind of muddy looking. See that? What is that? What's this? Look, look. Look at what I'm pointing. What is that? It's probably hard in the video to see, but you can kind of see the river carved out here. And that's the bottom of the river right there. You see it? Hey, you see it?
You see it?
What is this?
What is this?
What's that right there?
What's that right there? Right there.
No, to this. Point to this.
Point to this.
Here.
This one.
Yeah, exactly. What is that? What is it?
What is it?
Is that chocolate?
Chocolate?
Yes or no?
No?
No. Is that grass?
No.
No. What is it?
Is it on a mountain?
Yeah, there's mountains around it, huh?
Yes.
And what's this down here? This is the water,
the
right?
water?
That's the river.
That's the river.
Okay. That river, that little tiny river.
Little tiny river.
Yeah. That was what made
That
the
was what
mountains.
made the mountains.
See? That's a lot. Huh. Let's watch. Let's see how they explain it.
He came on a surveying expedition for the U.S. government. At the time, the Grand Canyon didn't even appear on many maps. It was part of a region written off simply as the Great Unknown. Newberry was the first scientist ever
See
to
the river?
descend down to the canyon's floor.
Look at that.
Once he set eyes on the Colorado River and studied the colorful layers of rock that towered above him, he proposed that the river itself had carved the canyon. It was a radical theory for the middle of the 19th century. It suggested that it would have taken millions of years to carve the canyon, which would mean that the Earth had to be much, much older than most people imagine. Today, most scientists agree that Newberry was right about how the canyon was formed.
Cool.
It all began about 6 million years ago, when the Colorado...
See this? See the river?
See the river?
So it's going down this way, right? See? What happens when the water hits up here? When the water's hitting right here? Watch. Look. Hey, not this one. We're done with this one. Here. I know. I know, you're distracted by it though. Look. When the water comes around here, the water's going to come around here, you see? And it's going to crash.
Did you water?
Yeah, that's the water, right? So the water comes over here, and you can see it crashes on there. It's going to crash into it. It's going to hit the dirt.
The dirt.
Uh-huh. What happens when the water crashes into the dirt? The water's going to crash into the dirt, and look, it's breaking off parts of it. Is it breaking?
Is it breaking?
Yep. This is starting to break. See? That's a really good picture right there. So this is starting to break. And it breaks. And when it breaks, the water takes it down. And you can see all these little pieces. These are all the pieces that the water is taking. Okay? You see that? So the water is breaking it and taking these down. And each of these is being taken away in the water. Does this water look clean? Is it clean or dirty?
Is it clean?
Does it look clean? What color is it?
Clean it?
Yeah, you need to clean it, huh? Yeah, it's brown, huh?
It's brown, huh?
It's brown because it has all the dirt. It's taking dirt with it, right? So it's taking all this dirt and it's taking it away. And these are all pieces that are being taken with it. And it's pulling it that way.
It's pulling that way.
So eventually, all of this will be gone. And it's going to be taken away. Because the river is going to take it away. It's going to keep crashing into it until it's gone. Does that make sense?
Does that make sense?
Okay. Hopefully.
The river first began flowing down and out of the Rocky Mountains and started carving a path through the Colorado Plateau.
Forces and
Nah. Okay. Well, there's that. So, at least for right now, I think that's what we've got. So, we got to get ready to... There's another one, huh? We've got to get some other stuff done too here, but we'll try and do an experiment, okay? Maybe we can post the experiment. We'll do it with water, okay? Does that sound fun?
Is that fun?
Okay, we'll do an experiment and post it too, but here's this for now.